Good afternoon, all my chemistry students. I hope this finds you doing really well. This is going to be a short little podcast that's not going to go specifically with any of your homework. So it's just some background information that we need to have to be able to move on. So the first thing we're going to talk about is a metallic bond. A metallic bond are cations surrounded by a sea of valence electrons. And you can see from the picture here that if you think about this as aluminum foil, aluminum is a metallic bond. So you have all these aluminum ions and you have these sea of electrons flying around the outside. And this is why you can make aluminum mold and bend, and all metals do that, is because they don't have distinct breaking points. Like you can't just break down a metal and it's going to crack along a nice little crevice. And so metallic bonds just have a sea of electrons. They're not too exciting. We don't really study too much about them because it's just ions floating around with electrons around it. Okay, then we talk about covalent bond. It's a type of bonding in which atoms share electrons. And what I'd like you guys to think about these is a tug of war. And if we have a tug of war that no one's really winning and you're always holding on to the end, then you have the difference between nonpolar and polar covalent bonds. So if you think about that tug of war, that we have a nonpolar covalent bond where the bonding electrons are shared equally. So no one's winning the tug of war. Something like this could be a hydrogen bonded to hydrogen. You can see that they both have the same size atom. They will be pulling with the same strength against each other. And this little stick that I drew here is representing two electrons that it's going to be sharing there with that bond. And if you look up at the periodic chart, those electrons are being shared because it wants to act like helium. So what it's really doing, if I take a look and draw a hydrogen, so I have my hydrogen bonded to my hydrogen, and I have hydrogen's one electron, and then hydrogen's other electron. You can see that they are sharing those two electrons in the middle, forming that bond, and so they both have noble gas configuration, and they're very stable at this point. So no one's winning the tug of war. Now if I go to polar covalent bonds, bonding electrons are shared unequally. So if I take a look and keep my hydrogen in here, and I put an H bonded to a fluorine, you can see that hydrogen is much, much smaller, so it probably would look something like this, with a huge fluorine that's bonded next to it. They're still sharing those electrons in the middle there, but this is an uneven tug of war. So there's going to be a positive side and a negative side, and that's what makes this a polar covalent bond. When I go back to my nonpolar one, there's no charge here, there's no excess of charge, and so they are pulling evenly on each side. We'll talk in a minute where those charges are coming from. So first we just have this bond continuum to get you to kind of understand the different types of bonds. And we're going to talk more about these in class. But metallic is a sea of delocalized valence electrons. So we're just talking about something like copper, I mentioned aluminum, iron, any of those metals that you know. Then we have ionic bonding is a transfer of electrons, and that's what you were doing in homeworks 1, 2, and 3. And we talked a lot about that it's usually a metallic cation, which gave you that positive charge, to a non-metal anion that gave you the negative charge. And so we have a positive bonding with the negative. So some examples would be like calcium plus 2, oxygen with this minus 2 charge gives you calcium oxide. I have a metal and a non-metal. Or plain old table salt that you have at home, NaCl, comes from the sodium transferring 1, chlorine taking that in, getting NaCl. Again, I have a metal to a non-metal. Then I have my covalent bonding where they are sharing their electrons. And if they're going to share their electrons, they are going to either be a polar covalent bond or a nonpolar covalent bond. And if we take a look at both of these, they have unequal sharing, usually two nonmetals. So hydrochloric acid, we've used that in class, or plain old water would be considered a polar covalent bond. And then for covalent bonding, we talked about hydrogen, oxygen, any of the diatomic gases. CH4 you can add here. We'll talk about that one also too, and as to why it's going to be nonpolar. So the biggest thing you need to figure out between these is what type of element you have. So here I have plain old metal. For ionic, I have a metal plus a non-metal. And then over here I have two non-metals, just for clearly identifying. Okay, so we're going to talk a little bit about electronegativity today, and you can find that on your periodic chart. And this helps us figure out the type of bond determined by the difference in electronegativity. And what it is it's a tendency to attract electrons. Now, we talked about ionization energy, where you are going to remove an electron and something's going to give it away. Here, we're not giving anything away, they're just attracted to one side more than the other. So noble gases are not sign electronegativities because they don't form any compounds. They don't want to react. But an example that I have over here, I have hydrogen fluoride. And kind of what I was showing you before is that I showed you that the hydrogen was much smaller and then the fluorine was a larger molecule. What happens is fluorine is the greatest electronegativity molecule that we have. And so I would draw it as H bonded to F. They are sharing those two electrons. And if you look at the electronegativity, fluorine is going to be the largest on the entire periodic chart. So what that means is that the electrons, these electrons, are closer to the fluorine than they are to the hydrogen. So they're all getting pulled to the fluorine. So what that means is that this side is going to become slightly negative, this side is going to be slightly positive. And we draw electronegativity lines with a positive side and then an arrow going to the side that's going to be negative. So let me show you that one more time here with water. So if we take a look at water, we're going to learn how to draw some of these compounds in the next podcast. But here we're just going to say that we have oxygen, we have hydrogen bonded to it, and they are sharing those electrons. And if I look at the electronegativity of these, you can see that I have lone pair of electrons, and this will all make sense when we start drawing these, but we know electrons are negative. So that means that my electronegativity line, and it might be good to grab some different colors, my electronegativity line is going to go towards the oxygen. There's more negativity, negative charge towards the oxygen. The same thing on this side of my overall molecule. So that makes my hydrogen side slightly positive and my oxygen slightly negative, and this is going to be slightly positive. Now this lends to the fact as to surface tension and why with water that you can skip a rock across the top, or you've seen bugs walk across the top of water, is because if we take a look, the next water molecule that's going to come into here is going to be attracted, those charges are going to be attracted to each other. So here I have my oxygen that's going to be slightly negative. I have this attraction here between these two. That's why water bubbles after you put it onto something, like you wash your car and you wax it up, and then of course it's going to rain, and when it does you get all those great little bubbles on the top of the hood of your vehicle. It's because of that attraction. It's surface tension. So electronegativity is more general than the other trends that we have been taking a look at. Again, electronegativity is the attractiveness of the molecule. How well is it going to attract electrons? So generally across the periodic chart, as across the period, it's going to increase. And down the side, as I go down a family, it's going to generally decrease. And again, that should make sense to you here because you're getting into higher energy levels. And so that force of attraction isn't going to be as strong. Okay, that is just a little podcast here. With polarity, you guys have the bond polarities, the difference between electronegativity values, as I already mentioned. Go ahead and try to do these practice problems. We are going to look at these and discuss these in class and make sure that you understand them. Okay, that is podcasts for this chapter, so have a wonderful night, and I'll see you soon in class.